So in example 5, we kick things up a notch. Notice just like a previous example, example 2 it was, just like with example 2, we have corresponding angles. They share the same position. They're both in the lower left-hand corner if you draw in that box there. So we know that corresponding angles need to be equal. That's our corresponding angles converse. These angles need to be equal. But the equation we set up has a little more going on because there's now an expression involving x on both sides of this equation. So to deal with that, the common way we mess with it is to pick on the little guy. 5x is smaller than 8x, so we can subtract 5x from both sides. That will move all of my variables to the left. So if we're doing that, we want to move our constants to the right. Adding 17 to both sides will allow us to do that. 8 take away 5 is 3. And on the right-hand side, 19 plus 17 is 36. Last but not least, a bit of division. And we find that x is 12. So same process we've been using, just the algebra steps it up a notch. But here we do have a pick on the little guy problem. Winds up being 3 steps instead of the 2 we were looking at before. So this was an example where there was equality. We wanted these two angles to be equal. Let's jump over to 6. In example 6, notice now what we have are angles on the same side of the transversal, highlighting the transversal there in blue. Both my yellow angle and my green angle are on the left side of the transversal. So they are consecutive. They are consecutive and they are exterior. So the converse we're going to use here is a consecutive exterior angles converse, which tells us that these angles should not be equal, they should be supplementary. Recall, supplementary is when you add them together and they equal 180. So adding in a bit of highlighter there, 12x minus 29, that's my yellow angle. 4x plus 1 is my green angle. That 180 is coming from the definition of supplementary. So we did an example of this already back in number 3. Note what makes number 6 a bit more difficult is I now have like terms with my x. My x terms are like terms as well. So I've got my 12x and a 4x. I can combine those like terms to be a 16x. And then I also have the negative 29 and a positive 1. Combining those like terms gives me a negative 28. So be careful when combining like terms. Make sure that, that you combine all of your like terms. You may have terms with x's in them. You may just have constants. But whatever you have on one side of the equation, make sure you bring all of your like terms together. This just becomes a 2-step equation, the same 2-step equations we've been looking at all day. We can add 28 to both sides. Adding 28 to both sides leaves us with 16x on the left. And we get 208 on the right. Last but not least, dividing both sides by 16. 208 divided by 16 is 13. So there we have an example where the angles need to be supplementary instead of congruent. So again, making sure that you line up the angle pair. What do you have? In this case, it was consecutive exterior angles, and we're using the converse there to prove A is parallel to B.